Hi everyone, my name is Christina, and in this video, I'm going to attempt the Kaggle Titanic challenge for the very first time. One of my goals for 2023 is to get better at machine learning, and I figured why not share my learning process online? One of the challenges I've always had with any type of coding tutorials is that they are usually made after the code has been figured out, which omits the entire process of how to figure it out. So when I eventually try to do something myself and not follow a tutorial anymore, I find that it's very hard to make that transition. So in this video and my future videos, I'm just going to record my first attempt of doing these type of coding challenges and share the entire learning process. With any type of coding, it's not just about writing code. There's also a lot of Googling and figuring out what code to write. And in this first attempt I'm sharing here, I have made some mistakes. I missed some things, but that's just the reality of doing anything. And the goal is to improve over time. Let me know if you find this helpful.
All right, so I'm logging into Kaggle here using my Google account, and I'm going to find the Titanic challenge. I've already joined the competition a while ago and just never did it. So here I'm just reminding myself of the rules of the competition. And also there's a really good YouTube video on how to get started, which is what I'm watching right now here. I definitely recommend watching this YouTube video. It kind of gets you into it as opposed to, kind of getting started with a blank page. And it also gives you a link to a tutorial, which I'm accessing here right now. And I will be following, or not really following, but looking at it as I try to figure out how to do this challenge. So this Titanic tutorial kind of covers the challenge, also tells you what kind of files are provided. So in this case, there's a train, test, and gender submission, CSV files provided. Gender submission is an example of what the submission file should look like, which is very helpful. It also gives you some guidance on how to access the notebook from within Kaggle. It's really nice that you can code from within Kaggle. You don't need to set anything up. It also looks like it comes with some main packages already pre-installed, so all you need to do is import them. And here it's showing the path of where to access the files from and how to load the data. So now that I know how to access the notebook for writing code, that's what I'm doing right now. Well, first I'm looking at the data. It looks like they provide dictionaries for what each column means. I actually don't spend much time here. I like to go into the data with code right away and then go back to the descriptions to figure out anything that's unclear to me. And here I'm starting my first ever notebook. I've never coded in the Kaggle notebook before, so this is the first time I'm accessing this. And looks like they already provide one cell with some of the packages like NumPy and Pandas. And here I'm just exploring the side, the right hand side of the page and what's in there, taking a look at what's in the cell that they provide, and starting my first code cell. It takes a little bit of time to get the session started, and looks like there is a code and markdown options to choose from. Here I'm starting with a markdown to just annotate the notebook a little bit. I don't really go overboard too much, just something to navigate, and right away getting into the training set to explore the different features and see which features are most likely to be predictive of who will survive or not survive the Titanic crash. Here, I for my job, I code in R and Python, so I always mix the two, as you might have just seen. The first thing I do is look at the head of the table, just to get a sense of what kind of values are in each column, whether the values are discrete, meaning they're characters such as male, female, or continuous, like age, fair, or maybe logical, like the survived column where 0 means did not survive and 1 means survived. Some of the columns I don't actually know what they mean, so I do need to go and take a look at the dictionary, which I forgot where to find it. I was just looking at it earlier. So here I'm just trying to see where it is. And here it is. So the SIBSP, didn't know what it was. This looks like siblings and spouses. Parch seems like it's parents and children. A board, so that's helpful. So here I'm just going to make a markdown cell and just write it all out what these column means. So I have it all in the same notebook, and I don't have to go back and forth to check or to remind myself what each of the values of each of the column names mean. And now that I have all the information in one place, it's time to figure out which features are actually predictive of who survived and who didn't survive. So here I'm just splitting the training set into two tables, one for survived and one for not survived. And then just taking a look at the summary, which I can never remember what the command is. And now that I'm looking at it, it would have been helpful if I spelled summary correctly. But I need to actually go in and Google to remind myself what that summarize or whatever the command is. And this is actually the majority of the coding process for me. I constantly forget, especially when I code in multiple languages. I need to remind myself what the correct command is. And here I actually stumbled across this skew command that I didn't know for pandas, and I thought it was very interesting, and I definitely want to explore that sometime later. So I noted that down and just going through different pages. And here, finally, I find the command that I was looking for. It's not summary, it's not summarize, it's actually describe, that gives some useful statistics for each of the columns. Now I'm taking a look at the count and mean for each of the columns. It looks like age does not every passenger or not every row has an age value in it, so that may be imputed in the future. I also just noticed that the minimum age is 0.42, which that has to be a mistake, so that's indicative that the data is not entirely clean. Here I went up for some reason and I realized that each line didn't render properly, so I'm just fixing it because I can't really look at it otherwise. And then also running the describe function for the not survived for comparison. So what I'm noticing here is that age is actually roughly the same for not survived and survived, but there's a clear difference in class and fair, as well as maybe the sibling, spouse, and parent, children, but there is quite a bit of standard deviation that may not necessarily mean that they're very predictive. I don't know. This is just the first glance at the data that I'm doing. The describe function doesn't provide any statistics for discrete values like sex. So here I'm checking how many males or females were in the survived versus not survived table. And there's a clear trend here of females surviving way more than males. And I'm checking to see what kind of other columns are that weren't in the describe output. And one of these other columns is the embarked column that has information of which port what passenger came from. So I'm just checking here in the survived versus not survived, what kind of numbers are from each port. And here I'm also realizing that looking at numbers is not exactly a good way of doing it. The best way is looking at percentage or proportion survived or didn't survive. So here I'm just copying the code from the tutorial for getting percentages. I'm fine with copying the code in from somewhere else as long as I fully understand what the code does. In this case, I do. Otherwise, I do want to first understand the code before I'm copying it. But in this case, I was too lazy to just type it out, and it was already available, and I understand what it does. So I'm just adjusting it to get both male and female survive percentages, and it's clear that females survive much more than males, which makes sense because from the movie, it was get all the women and children first and then the men, so it makes sense. And it's kind of cool to see that in the data as well. So next, I'm trying to figure out what other columns I want to check out the same way to see percentage survived and not survived for specific data value. And in this case, I chose class. I do remember from the describe tables, from the survived and not survived table, that the class seemed to be different across the two tables, where in the survived table, the average class was something like 1.9 or something like that, while in the not survived table, the class was over 2 point something. And here I'm seeing exactly that class does appear to predict, in some sense, survival, with class 1 surviving the most, especially compared to class 3. And at this point, I decided to start writing down which features I think matter and which features should ultimately go into the model for predicting who will survive and who will not. So here I'm noting down that sex is clearly predictive, class is definitely predictive, and next I'll have to figure out what other features, if any, more features are predictive. And for my next feature, I choose the parent children column to explore, and I first decided to plot a histogram of the parent children values just to get an idea of what they look like, in the what kind of distribution I'm working with here. I had to import the matplotlib package because it wasn't important, and here I'm plotting survived versus not survived tables. I didn't really find the histograms useful, again, just because I plotted the counts as opposed to proportions, so I decided to just continue with the same code for getting the proportions. And here I'm getting proportions of passengers with 0 children parent values versus more than 0, so at least 1. Before I actually see the outputs, I do like to guess what I think the proportions are going to be for this feature, and I'm expecting someone with at least 1 parent children to survive more than someone with 0 parent children value. Just because I feel like if someone is by themselves, then it's probably a male, just because back in the day, women didn't used to travel by themselves. Um, and here, I'm actually seeing exactly the case that it's exactly the case with someone with at least 1 parent children survive 50% of the time versus someone by themselves only 30% of the time. Next, I'm copy pasting the code and adjusting it for instead of having parent children columns to check the sibling spouse columns. I'm expecting similar trends here with someone who has at least 1 sibling spouse to survive more than someone without. Just because, again, if there is at least 1 sibling spouse, that means there is a female in the mix who is much more likely to survive, and I can see that that's exactly the case. And I'm noting that feature down as well as one of the features to include in the model. Next, I'm doing some more histograms of the fare. And I can see already here that whoever paid more for the ticket also survived more. Again, this is counts, but this does seem to make sense just because we already know from class of the ticket that class 1 survives more than class 3. and that should be correlative with the fair. So I put down fair as maybe just because I already have a class in the features to include. Um, so I've decided to maybe not include it in my first attempt. And then here I'm just adding more of the same code for port to see who survived more from which port. And I do see that there is some differences. For example, someone from port C, I don't remember which name it was, but from port C survived 50% of the time compared to the other ports. Maybe the reason for that is that maybe wealthier people live in the area where port C is more than other ports. I'm actually checking that here where I look at each port and what counts per class I have in each port. Um, and I actually do see that port C has the highest proportion of class one passengers. So this might make sense. In which case, I've decided not to include port in my first attempt just because, again, it's, I guess, correlated with class, and I didn't want to include redundant features. I did want to be a bit more conservative for my first attempt, and there's going to be more than one attempt. And now that I have all my features decided, and I did not include cabin or name in there just because there's so many values, so many unique values for cabin and name that it didn't make sense for me to include it in my first attempt, at least. So, and actually taking a look at the tutorial now, I see that in the tutorial, the four classes were also selected. So I kind of got a confirmation here that I may be on the correct path, at least for this first time exercise. So next, it actually comes the part that I'm not really that familiar with. I do have some basic understanding of some of the machine learning models, but not really how to implement them. So here I'm just kind of looking at the tutorial a bit more to see how to do this next part, because that's the part uh, of the most learning that I need to do. This tutorial utilizes a random forest model, which builds these trees and see if a given passenger belongs to a specific category and determines whether, they're gonna survive or not. While looking at the tree in the tutorial, I noticed that they put the passenger with more than four parent children value into a not survive category. So I went back to the data to see if the survival starts going down if I increase the number of parent children. And so here I'm going up to at least two parent children. And I do see that the survival actually starts going down. It's no longer 50%, it's a little bit lower. And that's actually a good lesson for me. I thought that having more parent children meant to more survival, which made so much sense to me that I didn't even check higher values, and I should have definitely done that in the first place. Next, I'm taking a look at the tutorial again. I do see this get dummies command, which I don't know what it does, so I'm not just gonna copy it before I understand it. And I've also decided to not just do the random forest classifier how the tutorial does it. Instead, I wanted to first understand why random forest classifier is used. So I ended up Googling it and reading up about it a little bit. And I also Googled classifiers similar to the random forest model just to see what else is out there and kind of plan for the future to test some additional ones. XGBoost, I'm somewhat familiar with. I have seen it being done, and I'm just taking a look at some of the blogs for other similar classifiers that I should use later on. I am pretty familiar with a support vector machine, so I just wanted to see what the difference is. And really what I wanted to understand when to use which model. There's so many models out there that I don't really know how to choose one. And what it says here is that random forest is good for multi-class problems, while support vector machine is more for the two class, and I do have multiple features. I do think my problem is multi-class. So this does make sense why I would want to use a model like a random forest model as opposed to the support vector machines. Now that I kind of have an idea on why I would use random forest classifier model, I'm Googling the documentation for the command in sklearn. Whenever I use a tutorial or code from the tutorial, I do like to, instead of copying the code directly from the tutorial, is Googling the command and figuring out how to run it from the documentation for that command. I feel like it's just a good practice to read documentation for code. So here I'm just importing the random forest classifier, how it says in the documentation example, and looking up the documentation for that command from within code with a question mark. It does seem like they're basically matching. So I go back to the website just because it's easier to read and look up um, how to prepare the input parameters for the command. And it's not exactly clear to me how to prepare the input parameters, so I end up going back to the tutorial to take a look how the tutorial does it. And I'm still intrigued by this get dummies command, so I ended up Googling it and taking a look at that documentation as well to get an understanding of what it may do before I use it. And at that point, I decided I'm actually just gonna try not to use it and see what happens. I assume it's gonna throw an error because there's probably a reason why the tutorial uses it. So, but I'm just gonna give it a go. And so I go back and copy the actual command for creating the model, um, and adjust the max depth and random state parameter to match the one in the tutorial. There is, I think, another parameter, the n iterations or something, but the default is 100 from reading in the documentation, and I believe the tutorial does the same, so I ended up just omitting it. So next I prepare the x and y parameter to go into the fitting of the model. So as I said, I'm not using the get dummies command. I'm just here picking out the columns that I've decided to feed into the model and simply making a y parameter where I just extract the survived column, which is the correct answers for each row, and then the x parameter, which is the all the extracted features that I've chosen. So now that I have the parameters, I go back to the documentation page to get the command for fitting the model and copy paste it back into the notebook. And as expected, it throws an error, most likely because I'm not using the get dummies function. And it actually gives me a link to this one hot encoding page about how to convert the parameters into what I need it to be, which is one hot encoded. So it seems like it didn't like that I had male, female. I think the module just doesn't know how to handle characters. And it actually says right here to use the get dummies function. So I'm gonna go ahead and use that now and then see what the feature data frame ended up getting converted into, just to make sure I understand what it's doing. So here I'm adding it on and then waiting for it to complete. And then I'm gonna just add another code cell and check. And I can see that the female, male, like the sex column got converted into two columns, one for male and one for female, and now it's one hot encoded. So I do no longer have these character values. So next I'm gonna go ahead and rerun the fit function, and now it will not be throwing an error anymore because it's seeing the correct input parameter format. And now I go back to the tutorial and documentation again to see what I need to do next. it seems like I'm gonna have to prepare the test table now to extract the features I'm using to predict and then input that test table into the predict function to get the answers or get the predictions for each row, which passenger survived and which didn't. So here I'm just reading in the test table now because I haven't done that yet, and I probably should have just read that in at the very beginning. So I have it. Here I'm trying to remember the path that I need to use to access these tables. So I just ended up just going up and copy pasting it and then extracting the features again with the get dummies function and then just running the predict function and saving it under the predictions variable. And here is the array of all the predictions. And now I'm just looking at the tutorial to see how I need to prepare the output for submission. So I'm just copy pasting so I get the exact output that will be accepted as my submission. So here's what the output looks like. It's a passenger ID from the test table and then the survived array with the predictions for each row. So now I'm saving that as a CSV and then saving the version of the notebook. I was a little bit confused at this part because I didn't quite know what to do next. I ended up just saving this notebook version, which reran the whole notebook from the very beginning. It took a little bit of time, but not too long. And then next, I just kept trying to figure out how to submit it. I finally saw the submit button after some time. Ended up cutting my search for the submit button out. So here I just pressed submit and it reran the notebook again, which was a bit annoying. And I actually ended up getting the score. You can see it on the right hand side of the page. I got 0.77511 from running this code and submitting these predictions. So I guess almost 80% prediction rate is not bad, but I'm very curious if we can improve that. So I ended up going into the competition page again and just looking at the leaderboard. And there are scores of one, which I don't really know how it was achieved. I can see that there's a bunch of usernames with just random letters on. So I'm guessing maybe there were some bots that kept getting created and basically brute forcing the predictions because some of them get it in the first try and there's just no way. I refuse to believe someone just got a score of one in a single try. So yeah, and then I took a look at a discussion to see if there's any advice that I can find for improving the score. Um, which is nice to see. It's nice to see other people's code just to get an idea or some inspiration for other models to use or check out. And that was really it for my first attempt. I learned how to use the Kaggle notebook. I learned how to do the predictions and then submit them and get the score. And I decided to stop here for now, not to get too overwhelmed, and will continue to try and improve this in the future.
Thank you for watching my first ever tutorial as I start this journey of getting better in machine learning. In this first video, I really just wanted to get through the entire process from start to finish. So learning how to use Kaggle, reading the data for the first time, exploring the data, and implementing one machine learning model, getting those predictions, submitting them, and receiving my first score. Obviously, I didn't fully understand what's going on behind the hood of that random forest classifier, and in my next video, I'm going to try to implement some additional models and see if I can improve the score, and that's also going to involve me understanding what's going on behind the hood of these classifiers and understanding the differences between them and when to choose which classifier, what does it depend on, etc. So that's it. Let me know if you found this helpful down in the comments, and also if you'd like me to slow down a little bit more. Turns out I typed slower than I thought, and I didn't want people waiting around as I just typed lines of code. But yeah, see you next time.